Okay, guys, running into some technical difficulties this morning. So hopefully I got it all squared away. Okay, so this was the next problem we were looking at. We want to get that into a form that we can talk about. So I'm going to take this 81 and write it as 9 squared. Okay, then we go to this sheet and we say, okay, well, it looks like we're in this form right here. So my x has to be a sine of theta, where a here is 9. So I have to substitute in x equals 9 sine of theta. Okay, so let's see, that means my dx is equal to 9 cosine theta d theta. Okay, so let's see what we got going on here. Square root of, I would have 9 squared minus x squared, which is 9 sine of theta, times my dx, which is 9 cosine theta, d theta. Okay, so let's see, what do I got going on here? Well, I've got a common factor of 9 squared. Okay, so if I pull that away, I'm going to be left with 1 minus sine squared theta. And then on the outside, I still have that 9 cosine theta d theta. Okay. All right, well, 1 minus sine squared is just cosine squared. Okay, so let's see. I have this 9 squared. Now it's times cosine squared theta times what's outside, my 9 cosine theta d theta. Okay, so let's see. This is a perfect square, so I can take the square root of it. And so I get 9 cosine theta times what's already outside, 9 cosine theta d theta. Okay, so it looks like I have a common multiplier of 81 from the 9 times 9, so I'll put that guy out front. And then cosine times cosine obviously is cosine squared of theta d theta. Okay, so we take a look there. We go to another sheet that we have, and we don't have anything for cosine squared. Okay, so that's not going to help us out. Okay, so let's see, what do I have to go to? Okay, how about my power reducing formulas? Okay, I can take this cosine squared and knock it down to cosine to the first power by using this substitution. So that's what I want to do. Okay, so let's see. I got my 81. Okay, cosine squared of theta would be 1/2 times the quantity of 1 plus cosine of 2 theta d theta. Okay, so now we're in good shape. Okay, so I can take that 1/2, put it out front. It's also a constant multiplier, so I get 81 halves out front, okay, of 1 plus cosine of 2 theta d theta. Okay, then I can integrate each one of these one at a time, but don't forget, each one of those integrals has a constant multiplier of 81 halves. Okay, so I have 81 halves times the integral of 1 d theta plus 81 halves times the integral of cosine 2 theta d theta. Okay, so let's see. This guy's real easy because that's like the integral of, 1 dx, so you just get x. So now it's the integral of 1 d theta, so I just get theta. Okay, so that's 81 halves times theta plus, now this guy I've got to use u substitution. So I go u equals 2 theta, which means my du is 2 d theta, which means I have 1/2 du equals d theta. Okay, so I've got that 81 halves to begin with. Okay, cosine of 2 theta becomes cosine of u times my d theta is 1/2 du. Okay, all right, so let's see. we've got our 81/2 theta plus, let's see, I would have the 81/2 times the 1/2, so that's 81/4 times the integral of cosine u, so that would be the sine of u. Okay, so I'd get sine of u, which is 2 theta, plus c. Okay, so where we're at right now, okay, we've got to get rid of those thetas. Okay, I need everything in terms of x for my answer. So I start by going back up here to this guy. Okay, so if I take that, x equals 9 sine of theta, I can figure out what theta is and make a substitution here. Okay, so let's see, that would be x over 9 equals sine of theta. So that means that theta has to be the arc sine of x over 9. Okay, so I can substitute that for theta right here. Okay, so let's see, we get 81/2 times the arc sine of x over 9. Okay, now I still got a problem with this sine of 2 theta, 81/4. Sine of 2 theta. So we have to go here, okay, to our double angle identities. And sine of 2 theta is equal to 2 sine theta cosine theta. So we make that substitution. So this would be times 2 sine theta cosine theta, and then we got our plus c there. Okay, so let's see what we got going on here. Okay, I've got this first half, it looks like I'm done with it, 81/2 arc sine of x over 9. Okay, I look here, notice that I have the 81/4 times 2, so I could cancel that 2 with a factor of 2 in the denominator here, so the 81/4 times 2 just becomes 81/2. So I have 81/2. Okay, sine of theta. Well, sine of theta is just x over 9 right here. So we can substitute in that x over 9. Okay, and then I have cosine theta. All right, well, let's see. Cosine squared is 1 minus sine squared theta. So cosine would be the square root of 1 minus sine squared theta. Okay, we're going in the right direction. Okay, again, this part of it's done. 81/2 arc sine of x over 9. Okay, notice right here I could cancel this 9 with a factor of 9 here in 81, so I'd get 9/2 times x. Okay, so I'm just getting 9x over 2. Okay, square root of sine. Well, sine is x over 9. So this sine squared would just be x over 9 squared. Okay, so we get 1 minus x over 9 squared plus c. Okay, we're in good shape here. We're almost done with this problem. As I said, that first half of it's already done. Okay, so let's see. I got this 9x over 2 square root of, well, let's see, this would be x squared over 81, and this would be 81 over 81, so I'd get 81 minus x squared all over 81 plus the c, and let's see, notice I can take the square root of 81 down here in the denominator, becomes a 9, and that'll cancel with this 9 up here. So we get 81/2 arc sine of x over 9 plus, remember that square root of 81 is 9, so that cancels here, so I'm left with x over 2 times the square root of 81 minus x squared plus c. And we got our answer. And we're in good shape. Okay. All right, I like that guy. Let's see. Let's try one more of these guys. Okay. And let's get organized here. Okay, so let's see what we're going to have. Okay. We are going to have the integral of, let's see, square root of, well, that would be radical 5 squared minus x squared dx. Okay. And obviously I'm going to need all the room I can use, so we're going to use this guy here. Okay, so let's see what happens here. Okay, so my a is radical 5. Okay, so again, I go back to this, and it looks like I'm in the exact same situation. So I've got to substitute in a times sine of theta, where a is radical 5. Okay, so let's see. My x equals a, which is radical 5, times sine of theta. Okay, so my dx would be radical 5 times cosine theta d theta. Okay, as far as the radicals, I'm going to worry about those guys at the very end. Okay, I'm not going to mess around with them right now. Okay, so let's see. Square root of, okay, we would have radical 5 squared minus this guy squared, radical 5 sine of theta squared, times my dx, which is radical 5 cosine theta d theta. Okay. Well, let's see. In here in the radicand, I have a constant multiplier of radical 5 squared, so I can pull that guy out. So we have radical 5 squared times, I would have 1 minus sine squared theta, and then outside I've got my radical 5 cosine theta d theta. Okay, let's see. Well, 1 minus sine squared is just cosine squared. So I get the square root of radical 5 squared times cosine squared theta times radical 5 cosine theta d theta. Okay, so now this radicand is a perfect square, so I take the square root of it and I get radical 5 cosine theta times radical 5 cosine theta d theta. Okay, so let's see, I've got a constant multiplier, radical 5 times radical 5, so that's just 5. So I can put that guy out front. Cosine theta times cosine theta is cosine theta squared d theta. Okay, and again, we know we're in that same situation where we can't integrate cosine squared of theta, so we go here to our power reducing formula, okay, and I make a substitution. Okay, so cosine squared of theta would be 1/2 times the quantity of 1 plus cosine of 2 theta d theta. Okay. All right, so let's see. We take that 1/2 out front, multiply it by the 5. So I got 5/2 out front. And I'm left with 1 plus cosine of 2 theta d theta. Okay, so again, I can split this up into two different integrals. And remember, both of those integrals will have a constant multiplier of 5/2. So I get 5/2 times the integral of 1 d theta plus 5/2 times the integral of cosine 2 theta d theta. Okay, so we know that this guy right here, we've got to do u substitution. Okay, so I use u equals 2 theta. So my du is 2 d theta. So I get 1/2 du equals d theta. Okay, so far so good. All right, so we know right here, this one's real easy. Okay, when we integrate 1 d theta, we just get theta. So I just have 5/2 times my theta plus, let's see. Here I've got a 1/2. Okay, this ends up being cosine of u and 1/2 du. So that 1/2 becomes a constant multiplier. Put it out front with a 5/2, so we get a 5/4. and then I would have the integral of cosine of u du, which is just sine of u. So we get sine of u, which is 2 theta, plus RC. Okay, so we've got to deal with these thetas now, just like in the last one. Okay, so let's see. First things first, let's deal with this guy. Okay, so I'm going to take this guy right here. Okay, and obviously if you have x equals radical 5 sine of theta, then that means x over radical 5 is sine of theta. So that means that theta is the arc sine of x over radical 5. Okay, so I can substitute that in right here. So we get 5 halves times the arc sine of x over radical 5. Plus, we've got our 5/4. Now the problem here is we have sine of 2 theta rather than sine of theta. So again, you go to your double angle identities right here. Sine of 2 theta is equal to 2 sine theta cosine theta, and that's what we substitute in. So sine of theta is equal to 2 sine theta cosine theta plus our constant of integration. Okay, so this part of it's done. Okay, so we've got our 5 halves arc sine of x over radical 5 plus, let's see, notice I have this 5/4 times 2, so that 2 cancels with the 2 in the denominator here, so the 5/4 goes back to 5 halves. So 5 halves. All right, I've got sine of theta. All right, well, we know that sine of theta is equal to x over radical 5, so we can just substitute in x over radical 5. Okay, and then cosine. Well, cosine squared would be 1 minus sine squared, so cosine would be the square root of 1 minus sine squared theta plus c. Okay. Again, I'm going to worry about these radicals later on. Okay, I'll deal with them later on. Okay, so let's see, 5 halves arc sine of x over radical 5. Okay, plus, let's see, that would give me 5x over 2 radical 5 times the square root of 1 minus. All right, now sine of theta is right here, x over radical 5. Okay, so that would be x over radical 5 squared plus c. And notice that at this point, all of our thetas are gone. Okay, so now it's just a matter of just cleaning things up. Okay, again, I'll worry about the radicals at the very end. We'll take a look at it. Okay, so 5 halves arc sine of x over radical 5 plus 5x all over 2 radical 5 times the square root of, let's see, this guy would be x squared over 5, so this would be 5 over 5. So we're going to get 5 minus x squared all over 5 plus c. Okay, 5 halves arc sine of x over radical 5 plus, let's see what happens here. Notice I can take this denominator, which is radical 5, and pull it out. So I'd have 5x over 2 radical 5 times 1 over radical 5 times the square root of 5 minus x squared plus c. And notice that this radical 5 times that radical 5 is 5, and therefore they cancel with the 5 up above. Okay, so we get 5 halves arc sine of x over radical 5 plus, remember these guys right here cancel with this guy up here, so we're just left with x over 2 times the square root of 5 minus x squared plus our constant of integration. Okay, and I would say that right here, there is nothing wrong with that answer. Okay, now if you wanted to right here, because obviously we don't have to do anything here. If you wanted to right here, okay, you wanted to rationalize that, we would get x radical 5 all over 5. Okay, you could make that substitution if you wanted to. I don't know if that's really necessary or not. That's completely up to you. So this guy right here, okay, that is your call. I don't think it makes a difference one way or the other. Okay, guys, I hope I have these technical difficulties taken care of. That'll take us to the end of the video today. And you guys stay safe out there, and I miss all of you.